Namaskar, welcome to my channel Best. So today we are going to see the topic on visualization of lines using parametric equation. We have already seen that how to derive the parametric equation of lines by considering two different methods, and those two different methods as are listed. Of the first method that we have seen, it was connecting the two endpoints. Second method that we have seen is one endpoint, length of the line and the direction of the line. So we have derived already the equation of this. Let me write that again. So by using first method, let's say we have 2 points, point P1 and point P2, two endpoints of a line. Then the parametric equation of the line is given as PU equal to your the point P1 plus U point P2 minus point P1, where this parameter U, it will ranging from 0 to 1. The second method is that we have given one endpoint, length of a line, and we have given the direction vector. Then the parametric equation of line will be given as following equation, which is P equal to your first point given to us, point P1 plus L, length of the line, times the unit vector, which is nothing but a direction, where this L is ranging from 0 to L max. So these two methods we have seen. We will see how to use these equations, parametric equations, to visualize the lines, and how can we use these equations to plot the lines graphically. The first method we are going to see is that connecting two endpoints. For this problem, I am considering this line which is given to us. The initial point P1 is over here. As you can see, the x coordinate is -9, y coordinate is -7. So P1 point is given. Point P2, x coordinate is 3, y coordinate is 10. So 2 points are given to us, P1 and P2, and we will see what is the parametric equation. It's easy. Given points are P1 equal to -9 comma -7, P2 is 3 comma 10. So the parametric equation of line is PU equal to, it was P1 plus U times P2 minus P1. P1 is -9 -7. I'm going to write this in matrix form, plus U, then P2 minus P1. So P2 is 3 comma 10. In matrix form it is 310 minus -9 -7. So in generally this matrices that we are writing, they generally are in the vertical form, and so that's why I'm putting this transpose symbol over here. So this would be -9 -7, and subtraction of this matrices will give me, it's 9 plus 3 and 10 plus 7 transpose. So this is the parametric equation of this line, right? And in this, the parameter U is ranging from 0 to 1. So if I'm going to put, let's say, U equal to 0, right? So now we are going to visualize that using this line, how can we get all the points. So using this equation which we got, I am going to solve that what are different points for this line. So I'm again writing that equation. So PU is -9 -7 plus U 12 and 17. So if you add these two matrices, it would be -9 plus 12U -7 plus 17U. And for your information, this is nothing but, it is your px coordinate of that point, and this is your y coordinate of any point on the line. So now let's use this equation, parametric equation, to get all the points. So what I will do, I will create a table for this. So I will take different values of u, and I will find what is pxu, and I will find what is pyu, which is nothing but your x and y coordinate. I will write the coordinates in xy terms. Okay, so now what we will do, we will put the value of u. First value of u is 0, so if I put u equal to 0 in this equation, I will get px as -9, py as -7. So the first coordinate is -9, -7. So -9 and -7 is this point. So -9 and -7 is going to be this point. This is the first point, -9, -7. After that, as you can see, the value of u is ranging from 0 to 1. So I will take few values which are in steps of 0.1 or 0.2. It's up to you. So let's say I will take 0.2 just for quick understanding. So I will take these points in steps of 2. So for 0.2, if you put the value of u 0.2 in the equation of px and py, we will get -6.6 and py -3.6. so the coordinates would be -6.6 comma -3.6, and that you can locate easily in the graph. Somewhere here the point will be located, which is -6.6 -3.6. Same way we will do for all other possible values of u. So I will quickly give you the values which I am getting if I put different values of u in the equation of px and py. So as you can see, these are the points which we got, and now we can just plot this point. So the third point is -4.2 and -0.2. So -4.2 and -0.2, it will be located over here. This is your third point. Fourth point -1.8, 3.2. The next point, it would be 0.6, 6.6, and last point is 3, 10. And now if you're going to just construct a line passing through all this point, and this would be 3, 2, because this is 3, this would be 3, 2. So you can see that you are getting the same line. And the next observation you can see is that just by varying the value of u between 0 to 1, you are getting 2D spatial line, right? You don't need to vary the x and y coordinates. Just by varying this, you are going to get the full 2D line. So that is the visualization of line using the first equation. Now you can see that how easy the method is. The next one is non-parametric method, which generally we have already done in our high school. So in non-parametric method, we are going to use a generic equation, which is, let's say, y equal to mx plus c. So the generic equation is, non-parametric equation is y equal to mx plus c, where m is slope of the line, which is your delta y by delta x, which is y2 minus y1 divided by x2 minus x1. We have p1 equal to -9 comma -7, which is x1 comma y1, and we have p2 as 3 comma 10, which is x2 comma y2. So slope we will get as 10 plus 7 divided by 3 plus 9, 17 by 12. So we got the slope. So the equation now we got as y equal to 17 by 12 x plus c. Now let's find this c. What we will do, we will take any of the point. So let's say we will take point P2. So I will have 10 equal to 17 by 12, x is 3 for this particular point, plus c, which will give me c equal to 23 by 4. Thus equation, non-parametric equation of line is going to be 17x by 12 plus 23 by 4. We can cross check this equation also by putting any point and then see what we are getting by putting, let's say, x coordinate. Are we going to get y coordinate or no? So let's do that also. So we got correct value of y, thus this equation is correct. So we got the non-parametric equation of the line. So now what you can see, that if you have this equation and you want to get all the points on the line, you have to vary the value of x and y, right? And you can see that the limits are, so limits of x, it would be from x1 to x2 and y1 to y2. What it means, x1, that we is having -9 to 3, and your value of y, it was varying from -7 to 10, right? So now in this case, if you want to, let's say, visualize the line, you have to vary your value of x between the ranges, between the limits from -9 to 3 and y from -7 to 10. Take any value of x. For that particular x, you will get y and you will get the coordinates. So this generally we will follow, and your initial value, it will be -9. So if you take -9 and put this -9 in the equation, your equation star 1, you will get the y value. So if you do this, you will get first point -9 -7, -9 comma -7, then you will vary to, you will go to -8, or you can go to, let's say, now as we have gone in the steps of 0.2, you can go to -7 also. So for -7, what will be the next point you have to do, you have to like find. So for mine, you will put this -7 again in the equation star 1, you will get one point which is -4.166. So this is your next point. Same way you can go to -5, find one more point, then you can go to -3. So you can go to now -3, find the point, then you can go to -1, lastly you can go to 1, and then last final point is going to be your 3, last point 3 with x equal to 3, which you will get 10. So now this coordinates which you got, you have to now plot this coordinate and get the line, and you will see that you will get the same line that we got earlier. So the differences between parametric and non-parametric equations is that you have limited interval, right? We are having a limited interval from 0 to 1, and between that we can get all the values. Second, easy to compute points. Third, it's flexible method. Fourth, you are doing localization, thus it is simple to use, it is a simple method. Fifth one, is easy to implement in algorithms. So for computer aided design in your systems, computers, generally this parametric equation will be easy to implement. Similarly, we can do the same exercise for one endpoint line and the direction method, where the equation that we have seen for parametric equation of a line is p equal to p1 plus l n cap. Okay, so now we have to find this length of the line and the unit vector of this line. It's easy. You have already given, let's say, point p1 and point p2. So length of the line is nothing but it's a square root of distances x2 minus x1 whole square plus y2 minus y1 whole square, and if you compute this comes out to be 20.8086, and the unit vector, it is nothing but it is p2 minus p1 divided by p2 minus p1 magnitude, which I can write in coordinate forms as x2 minus x1 divided by l I plus I cap plus y2 minus y1 divided by l j cap. X2 minus x1 is 3 minus minus 9, which is 12 by 20.8086 I cap plus this is 17 divided by 20.8086 j cap. So the unit vector is coming around 0.5766 I cap plus 0.8169 j cap. Thus the final parametric equation, it will be your first point p1, which is minus 9 minus 7. I am writing in the matrix form, plus L length, which is 20.8086, which is a constant, and multiplied by unit vector, which I can also write in matrix form as like this. Now in this case, if you can see over here, if I'm just putting this value of p as 20.8086, what it means, I am finding the last point of the line, so it's better to keep it as L, a parameter L, which will vary from 0 to L max. Right, so let's do this. We will put it as it is L. So I can have minus 9 minus 7 plus L, and if you solve this, you will get the equation of the parametric equation as minus 9 plus 0.5766 L minus 7 plus 0.8169 L. And in this equation, again same thing. If you remember, this term is nothing but it is px term, x coordinate of point P, and this is y coordinate of point P. So now what we will do, we got the equation, we will now try to plot the line, and we know what is the value of L. So let's create that table again, where we have different values of L, a parameter L over here, and as we are varying this parameter L, we are finding the value of px, we are finding the value of py, and we are finding the x and y coordinate. So first I will take L equal to 0. If I put L equal to 0, px will be minus 9, this is minus 7. So first point will be minus 9 comma minus 7. I have to vary this L till 20.8086, and in between I can take different points. Let's say I can take in steps of 5, steps of 4 or 2, it's up to you. The more point you will take, you will get more appropriate line in that case. So let's say I will take the steps in the steps of 5. So next point I will take 5, 10, 15 and 20. So I will go with 5 points. If I'll take L equal to 5, I will put this value of L equal to 5 in the equation of point P, which is star 2. So now I will take the value of L equal to 5 and I will find Px and Py. Now as you can see, I have computed all the x and y coordinate for different length of the line ranging from 0 to 2.8086. So make sure in this your first point when L is 0, this has to be your initial point, and when L is your L max, the last point it should be point P2. If this is like this, your calculation is correct. So now again what you will do, you will uh, um, now you will plot all these coordinates on the graph paper and you will get the line. Quickly we can plot first point minus 9 comma minus 7, second point minus 6.11 and minus 2.9, somewhere here. Then third point minus 3.24, 1.169, somewhere here. Then minus 0.351, 5.25, somewhere over here maybe, and last 0.3 comma 10. And now you can just try to connect this all the points. Maybe this point that we have, it is located somewhere over here. So minus 3.1.16, yeah, so this point will be somewhere over here. So we got first point, we got second point, third point, fourth and fifth. So this is all about how to visualize a line by considering the parametric equation, as well as I have shown you how to differentiate this method with respect to the non-parametric equation, as well as I will give you the last point in this case. So in the method 1, if you remember in this, so in this you can see that all these intervals, or you can say all these cells different length, generally they are of equal distances or equal length, because you have equal intervals of parameter u. In non-parametric you can see that again, if you are going to plot this, the line the length of the line will vary in this. X coordinate, let's say it is remaining same, but the difference of y coordinate, it is not same. Last one in this case also you can see, this is the distances which is not equal in this case, even though I have taken the length of the line in steps of 5. So ultimately the most important equation that is applicable for plotting a line is by using method 1, where we can get the plotting of line with same with the, so in this method 1 we can get the plotting of line with the segments of a line with equal length. So if you like this, so if this video is helpful to you, hit the like button and subscribe my channel best for more such videos. Thank you.